Here we are, Stats and Mechanics Year 1, Chapter 10, Question 11. A train of mass 2,500 kilos pushes carriages of mass 1,100. Pushes them. Okay, right then. So, one train, okay. What does a train look like? It's got to be a steam train, doesn't it? Okay, one train pushes carriages. Okay. Right then, pushes it along. The train has 2,500 kilos and the mass of the carriages is 1,100. Alright, down the train tracks, off we go. Right then, along a straight horizontal track, the engine is connected to the carriage by a shunt, which is parallel in the direction of motion. Horizontal resistance to motion of the train and the carriages have R and 500 respectively. So we've got a resistance of R on this one, and we've got a resistance of 500 newtons on the train carriage. Okay, the engine of the train produces a constant horizontal driving force of 8,000. Okay, so we've got 8,000 newtons coming in this direction. That causes the train and the carriages to accelerate at 1.75 meters a second. Okay. A. Show that the resistance to motion R acting on the train is 1,200. Okay, a lot of information on there. It is just F equals MA. And so in terms of going towards the right in a direction, we're going to have 8,000 from the train, take away the R from the train, take away the 500 from the carriages, is going to equal the mass, which is 2,500 of the train, plus the mass of the carriages, times the acceleration, 7.5, wasn't it? 1.75. Okay, bit of rearranging to do. So the right hand side there, 2,500 plus the 1,100, that gives us 3,600 times by 1.75 is 6,300. 6,300 on this side. 8,000 take away 500, of course, is 7,500. Okay, so we've got 7,500 minus R. So when we bring it across, 7,500, take away 6,300, gives us 1,200 newtons. Excellent. Right then, part B. Find the magnitude of the compression in the shunt. So we would normally, the compression is going to be basically what would be considered the tension forces inside the tow rope, but it's not, it's a solid fixed thing in a train. Okay, and so we want to have a look at that. So let's consider the train on its own here. Okay, find the magnitude of the compression of the shunt. So as we go forward with that, again, it's going to be F equals MA. The mass is the 2,500 and the A is the 1.75. Oops, previous question. Okay, so that does the MA bit. Now, in terms of the forces, we've got 8,000 going forward, and we've got the 1,200 200 coming to the right, and or to the left even, the resistance force, and we've also got what I have labelled up as a tension in here, okay, or this compression as they are calling it. Okay, so with that in mind, 8,000 take away 1,200, 7,000, 6,800, 6,800 plus T is equal to 2,500 multiplied by 1.75, which is 4,375, 4,375, and of course tension is that divided by the 6,800. No, it's not divided at all, it's done as a takeaway. Takeaway 6,800. Okay, and so this compression, or this tension as I'm calling it, 4,375 take away 6,800. Okay, 2425. 25, and it's minus, which shows that it's in that direction for there. Okay. So tension is 2425 newtons. The minus just gives us the answer, so the compression is equal to 2425 newtons. Okay. Right, the train. What's the train doing now? The train must stop at the next station, so the driver reduces the force produced by the engine to 0 and applies the brakes. The brakes produce a force on the train of 2,000 newtons, causing the engine and carriage to decelerate. Given the resistance to motion unchanged, find the magnitude of the thrust in the shunt. Give your answer correct to 3 significant figures. So let's consider a diagram again. Okay, so we've got a train. Let's simplify it down this time. Okay, which was 2,500. And it's got a resistance of 1,200. It also has we've got this coming in here on here for the shunt. Okay, we've got the 1,100 on there. 500 newtons this way. Was it 500 newtons this way? 500 newtons going this way. So what's happened? It's got a braking force now of 2,000 for the braking force on it. Okay. Given the resistance to motion unchanged, find the magnitude of the thrust in the shunt. So what have we done here? Cause the engine carriage to de-accelerate, give the resistance. So if we do F equals ma on that, if we take everything into consideration, the thrust, what force are we missing, and do we have the acceleration? I think we do have the acceleration of everything. Okay, so we can do F equals ma as the whole system, so we can have 1,000, well, it's going to be minus 1,200, minus 2,000, minus 500 for all of the forces is equal to the mass, 2,500, plus the 1,100 times A. Okay, and that's going to give us an acceleration, which will be negative, but that's correct because it's a deceleration, okay, which we can then use. So 1,200 and the 2,000 and the 500 gives us a total of 3,700. Okay, and that's getting divided by the 1,100 plus the 2,500, 3,600 equals A. So adding those up. All right, so 37 divided by 36 is 1.02. So I've lost my minus there. Minus 1.02. 777 is equal to the acceleration. So the whole thing is slowing down like that. Now then, we are looking for the thrust in here. Let's do it on the train carriage. Okay, just because we did it on the train last time. Okay, so now we're putting an F equals MA on here, and so I've got the, let's call it, what did they call it on theirs? They called it thrust. I use the T again then. Right, so minus 500 plus the T, okay, is equal to the 1,100 times by the 1.0277 that we just worked out in the previous part. Okay, and so the tension is equal to, multiply that by 1,100. That gives us 1130. 1130.55, adding 500 to it for there, plus the 500 gives us 1,000 thrust is equal to 1,630.5 newtons. Okay, that's it. Oh, it wants 3 significant places, so 1630 to newtons to 3 sig fig. Okay, I'll just check the back of the book and I can see I've made a mistake because the answer they've got is 630. Why is my answer 1,000 out? My answer is 1,000 out because I didn't bring my minus sign over. Okay, so when you bring your minus sign over, you get minus 1.02, you get minus 1,130, which means when you add 500 to it, you end up with 630, which means to 2 or 3 significant figures, it's 630 newtons. Okay, so not 1,630 but 630 newtons. Should that round up to 1? Not sure. No, I don't think it does. 630. Done. All right, good. Sorry about that.